Okay, number 7, it's given the trapezoid with JK parallel to ML. Use a compass and a straight edge to construct the altitude from vertex J to ML. Leave all construction marks. All right, the first move I would make is I might just extend this in case I need it. Extend the side a little bit. Okay. First move is if I want to move from J perpendicular to ML, what I'm going to create is 2 points on ML that are the same distance from J. All right, so this is going to be P1 and P2. I know P1 and P2 are the same distance from J right now. So then I'm going to, if I can get the perpendicular bisector of P1, P2, J will be on it, and it'll be perpendicular to side ML. So, perpendicular bisector of P1, P2. Pick a radius. I don't need one up top because I have J. Use the same radius over on P2. Center at P2. Same radius. They connect right there. Now I'll connect J to that point, and should be perpendicular to ML. Now we'll call this N. So Jn is an altitude from vertex J to ML. Basically, you have to know an altitude is perpendicular to the opposite side. All right, there's 7. Number 8, perpendicular bisector of AR. Okay, so we can't trust T. We don't know if it's an isosceles triangle, so we're going to assume it's not going to use T. Basically, all I have to do, find the perpendicular bisector is find the points that are the same distance from both A and R. We do that by drawing a circle with the same radius centered at A, and make sure it's a big enough circle, big enough radius, so that if we use the same size radius over on centered at R, what we need is those to cross, and they do. Now, make sure this circle is large enough to have a good amount of intersection, okay? I've seen where the arcs are too close together, they barely cross. That's a little dangerous. You want them to have a good amount of intersection there. So, if you construct that, that is the perpendicular bisector of side AR, right there. Okay, number 9. Construct a square inscribed in circle O. All right. Now, the way I do this, there's a number of correct ways to do this construction. I start with any random diameter. Okay. Now, a diameter simply has to pass through the center. So I will call this, I'm going to call my square ABCD. So this is going to be AC. That's going to be the diagonals of. I'm going to start with a diagonal of the triangle or the circle, the square. Sorry. Now, if I construct a perpendicular bisector of AC, I'm using the theorem for the diagonals of a square. They bisect each other, and they're perpendicular. Okay. Again, that's the diagonals of a square. So I'm going to construct a perpendicular bisector of AC. Again, perpendicular bisector, center your compass tool on A, choose a radius that's pretty reasonable, large enough. I probably don't have to go up top because I do have point O, but I'm going to anyway. I'm going to go back and get that radius because I lost it. It's this one. Okay, center at C, same size circle, and if I use my straight edge, okay, if I use my straight edge right there, all right, that segment there. Now, I've these 2 points are not going to help us construct a square. Remember, that's just the perpendicular bisector of AC. These are the points on the circle that are other points of the square. So this is B, this is D. Now, if we connect those points, we have a square. Very common construction for this course. Okay, so now ABCD is a square. And what we have to do now is determine the measure of the arc intercepted by 2 adjacent sides of the constructed square. Well, that should be pretty easy. What they're talking about is arc BC. Okay, arc BC's measure should be 90 degrees because the diagonals bisect each other and are perpendicular. Okay, so angle BOC is 90 degrees, the measure I should say, and central angle measures are equal to the measure of their intercepted arc. Okay, so that's what it looks like right there. All right, that was number 9. Number 10, what we're looking at is use a compass and a straight edge to construct a regular inscribed octagon in circle T below. Well, basically we're going to use the square. I'm going to do the same thing with the square. Sorry, I just put that. Okay. So I'm going to start with a random diameter again. Okay, so I need 8. We'll go A, B, C, D, E, F, G, H. That's going to be 8. This will be A and E. Yeah. Okay. Now, I'm going to now need to construct the perpendicular bisector again. This time I'll just go under. I'm going to use the fact that I have T. So I'm not going to go and do 2 big arcs. Just one's going to do it. Okay. Here's what I'm going to assume. T is definitely in the middle of A and E. So is this point. So they're both equal distances from A and E. So they're both on the perpendicular bisector. I'm confident that that is the perpendicular bisector. Now this point is on the circle, so these are going to be points C and G. So I'm just going every other. All right. What I'm going to do now is I could do angle bisector. I could bisect these segments. There's a lot of things that I could do. Why don't we just try angle bisector? It's been a while since I've done that, so I can practice this. So angle bisector starts with I'll do 2 of them at once. Starts with a random arc. Okay. What I'm going to do is I'm going to bisect basically this segment. I'm going to perpendicular bisect that segment. It's going to bisect the angle. Okay. So again, perpendicular bisector. Pick a radius. Random. Center is right there. Center is also right here. Now I know that's in the center, so I'm going to use it. Now that was the angle bisector of this angle. So that point's going to be the same distance from these. This point's the same distance from these. So that's going to be my B, what comes after EF. Now I can do the same thing again. I'm going to bisect this segment. Okay, there are a lot of ways to do this one, but this is one of them. Random radius. Shift the center, same radius. This is going to be an angle bisector for this angle. I'll keep going. Oh, I missed. Okay, right there. So after C is D, and after G is H. Okay, now connect all these. And we will have a regular octagon. Now, any octagon, you just need 8 random sides. A regular means all of them are spaced out the same, you know, all the points. All the sides are the same, all the interior angles are the same. So that's what makes it regular. Okay, 8-sided, and all equally spaced. Determine the measure of one inscribed angle of the octagon. Okay, so there's a few ways to do this. I always go exterior angles. Okay, so the distance right there. I look at the exterior angle measure, if you were to keep going. All the exterior angles add up to 360 degrees. There's 8 of them. So the exterior angles are 45 degrees each. Okay. Now an exterior angle and an interior angle, right here, that's 45. The interior angle with that is going to add to 180. So 180 minus 45 is 135. Now I know there's a ton of ways to do that. But each exterior angle, the measure of each inscribed angle, we'll call it angle AHG, is 135 degrees. Okay? There's a number of ways to do that, but that was one of them. Number 11. All right, construct an equilateral triangle. All right, so the equilateral triangle construction that I use is the same one I use for hexagon. Okay, then, you know, number of ways we could do this. What we're going to do is my triangle is going to be ABC, but I'm going to have to call this a different letter because we're not going to use this point. Let's just call it D. All right. Now, what I'm going to do with A is I'm going to center my compass tool at A, find the radius, it's probably, let's toss up between those two. I'll use this one. Okay, I'm going to have a radius so that it crosses right through T. Now these two locations, these will be the same distance from A. Now if I use the same radius there, spin around to D, whoops, something doesn't look right there. Maybe it's a different radius. Yeah, right here, sorry about that. Same radius. These 2 points are now the same distance from D. Now I have 6 equally spaced points. Along the circle. If I use every other one, that's going to be 3 equally spaced points. So A, B, C. I'm going to connect those, and what I've just constructed is an equilateral triangle. Now if I wanted a regular hexagon, I'd just simply connect all 6 of them. So that's how I would do it. Okay, those are all the same. Determine the measure of the arc intercepted by one of the sides of the triangle. Okay, so 360 degrees, okay, divided by 3 equal sides, 120. So let's see, the measure of arc AB is 120 degrees because there are 3 congruent sides. So 3 congruent intercepted arcs. 180 degrees divided, oops, I'm sorry, 360 degrees is all the way around, divided by 3 is 120 degrees. So when we explain, we've got to make sure we have some sentences there. All right, almost done. Number 12. Use a compass and a straight edge, construct a regular hexagon, we're going to basically do the same thing as we just did. Okay, random diameter. That's going to be AD. Okay, put our compass tool on A, find the radius that passes through the center, switch it around to D. Hopefully it's the same radius, yes, should be. Now these 6 points are all equally spaced apart, so this is B, C, D, E, F. Got to connect them to get full credit. I've seen that before where students do this correct. One year we had this on the final and we didn't have it. You know, a good number of students didn't connect them. Got the right idea but didn't connect them. So make sure you connect them. Okay, just locating the 6 points is the main idea, but then you got to connect them to get the hexagon. All right, if chords FB and FC, oh, sorry about this. I wish I had a different color on me. Okay, so try to highlight this right here, this triangle. Okay, follow that one. According to its angles, which type of triangle would triangle FBC be? Well, this is a right angle right here because FC is a diameter. So, first, triangle FBC is a right triangle. Explain why, since FC is a diameter, angle FBC is a right angle, okay, because it is an inscribed angle, that opens to a, you could say semicircle, diameter, 180 degree arc. It's 180 degrees from F to C. I'm going to say opens to a diameter. So it is a right angle. Now that's probably not perfect, but it's good enough to score us the points we need. All right, 2 more. Let's see, construct an equilateral triangle with RS as one of the sides. All right, so this shouldn't be too bad. I'm going to put my compass tool on R. I'm going to find the radius that is going to pass through S, this one. And I'm going to draw a big enough arc. I don't have to go all the way this way, I'm just going to use this one. Okay. Now make sure you pass through S, so there's evidence you use this to construct. Now it should be the same arc, but I'm going to center at S, and I'm going to use the same radius. Okay, it hits R. See how it passes through R? And now this location is the same distance from both R and S, but it's even more important. If I connect all of these, not only is it the same distance from both of them, but this is also the same distance as RS, and so is this. Okay, leave all construction marks. It's probably just a 2-point question. We'll call it T. All right, triangle RST is equilateral. We don't really have to explain. There it is. All right, last one. Construct and label the mid-segment DE. Mid-segment DE of triangle ABC. D is the midpoint of side BC, and E is the midpoint of side AC. All right, so we got to get the midpoint of these. The only way I know how to do that is perpendicular bisect. All right, so I'm going to perpendicular bisect AB first. Let's use this radius. Same radius over centered at B. All right, so that's a perpendicular bisector. I know that that's not what we're after. We're after the midpoint. But we use perpendicular bisector to get the midpoint. D is the midpoint of side AB, so that's D. All right, it's going to get messy, but now we got to do the same thing. I'll try to stay away from these as best I can. Okay, there's a radius from A. We'll come over here to C. Just kind of getting in the way here. Just want to use that same radius. Okay, now be careful here. This is a mess, but right there, that's another perpendicular bisector. All right, that is the point E. Okay, now connect those, I think. Yeah. And we have to talk about why is triangle ADE similar to triangle ABC. Okay. There's a number of reasons we could do this. Midpoints. Yeah, I'm going to use this. Okay. So since D is the midpoint of AB, AD is half the length of AB. Okay? Since E is the midpoint, and it's just an explain, it's not a proof. Since E is the midpoint of AC, AE is half of AC. Okay, now summarize those two statements. Sides AB to AD and AC to AE are proportional. Same ratio, right? 1 to 2 or 2 to 1, whichever way you want to look at it. And now angle A is congruent to itself, right? See this angle? By reflexive property. And finally, triangle ADE is similar to triangle ABC by the side angle side triangle similarity postulate. And that is it for our constructions. Thanks so much for tuning in.